find the integral dx over x squared times the square root of x squared plus 9. So this is done by trig sub. We're going to let x be equal to 3 tangent theta. This is a u squared plus a squared situation. So dx is going to be 3 secant squared theta d theta. Okay, so let's see what happens to the radical term in the denominator. X squared plus 9 will now become, according to that substitution, 3 tan theta squared plus 9. Square that, we get 9 tan squared theta plus 9, and then you can factor out the 9 from under the radical, leaving us with tan squared theta plus 1 times 9 under the radical. Change the tan squared theta plus 1 into secant squared theta, and so we get 9 secant squared theta. Take the square root of that and we're left with 3 secant theta. So that means our integral is going to change into the dx on the top becomes 3 secant squared theta d theta, and in the denominator we have an x squared there, so that's going to be 3 tan theta quantity squared, and then we just went through and saw that the square root of x squared plus 9 becomes 3 secant theta. Okay, so just to be clear here, the dx right there, that's this. That becomes all of this in the numerator. The x squared right there, this is what x is. So we plug that in and square it right there. And then finally, x squared plus 9. We went through and saw that that was equal to 3 secant theta. So this is our new integral. Let's see what cancels. We've got 3 and a 3 here. We'll cancel. Secant squared. We'll cancel with that secant there. And it looks like we're left with, if you square that 3 in the denominator, you have a 9. So we'll pull that out. 1/9. What do we have left in the numerator? Secant theta d theta. And what do we have in the denominator? We've got tan squared theta. So the best way to deal with this would be to write everything in terms of sines and cosines. So let's do that. Secant would be 1 over cosine. And then that tan squared in the denominator, you can write that as cotan squared in the numerator, which becomes cosine squared over sine squared. Okay, then this cosine will cancel with that second power of the cosine in the numerator there, and we're left with cosine over sine squared. Cosine over sine squared. Now this could be done with a substitution. You could let u be sine and then du be cosine. You'd end up with du over u squared, although you could also write this as cosine over sine and then multiply that by 1 over sine. Same thing. And then just realize that this is the same as cotangent, cosecant, and we should hopefully recognize that as one of our 6 pretty easy trig antiderivatives. It's just negative cosecant. So we get negative 1/9 cosecant theta plus some constant. Then we have to change this back into x in terms of x. So we'll come back up and look at our original substitution. X was equal to 3 tan theta. So we can draw a triangle if x is equal to 3 tan theta. That tells us that tan theta is equal to x over 3. We can draw that our triangle with that. this is theta, we know that the tangent of theta is x over 3. So we can put an x in the opposite, 3 in the adjacent. That's how tangent is defined in a triangle, right triangle. And that makes the third side be x squared plus 9, which if you notice is the same as the term that we had in the original integral up here, x squared plus 9 right there. That pretty much always happens. I haven't seen a case where it doesn't. And then that means that negative 1/9 cosecant theta is going to be equal to negative 1/9 times the cosecant of that angle that we just drew over there. And the cosecant again is defined to be the opposite side, or sorry, the hypotenuse square root of x squared plus 9 over the opposite side, which is just x. And so final answer here, negative square root x squared plus 9 over x, over 9x plus c.